Hello everyone. So in this video we will see how we can do the regression analysis using the Excel. So we are going to solve this problem. So a person travels by car. They record their miles driven by in a data table. What is the estimated regression equation that relates the driving time to the distance traveled by? So here is the data given, time driving, which is X, and distance traveled, which is Y. Now, to solve it using the Excel, we should have a data analysis tab, which you can get it in data tab. So if you don't have data analysis in your Excel, what you have to do is you need to click file and then you have to click the options. So once you click the options, you will just click add-ins. And if you click add-ins, you will see the analysis tool pack and you have to go click here go. So click this one go and you will see this analysis tool pack. So you will click the first one and the second one, analysis tool pack VBA, and press OK. And you will see the data analysis tab here in your data tab. Once you get the data analysis tab, so you have to click the data analysis for that, and you want the regression analysis, so you have to check here the regression. So this regression you need to click and then press OK. So it will give this dialog box, so where the first line says input Y range. So you have to input the Y range, so you can input the complete range and then input X range. So we can input the X range. We have also included the labels while selection, so we can click it. If you are not including the labels, you don't click this one. Now where you want the output, so you have to click. You can get it in new worksheet or you can get it in the same worksheet. So suppose I want to get it in the same worksheet, so I will click this output range and I will click this one and select the cell. So suppose I want to select this cell and then we can press OK. So we get the complete regression analysis. Now you have all the data here. So now you can round off each value whatever is required till 2 decimal place. So you can click home and then click this button. So your values will be till 2 decimal place, which is more like easy to read. So I can click till 2 decimal place, your p-values as well. Right now we have all this data, so now we can answer one by one all the questions. So let's see what were the questions here. So the first question is, what is the estimated regression equation that relates the driving time x to the distance traveled y? So you have to write the regression equation here. So for the first regression equation here, it is your y is equal to m, that is slope, and slope is given by this one. So 61.93 x and minus 1.79. So y is our distance traveled. So I can write that distance traveled is equal to 61.93 times time driving and minus 1.7. The second one is the regression relationship significant? Use the p-value approach and 1% level of significance. So for that, we will always test the null hypothesis that there is no relation between the x and y, that is time driving and distance travel, and your alternative hypothesis will be always there is a significant difference between x and y. Now we will check the p-value, and here your p-value is so this one is your p-value, which is less than. So it is your 0.000. There is 9 decimal points, so 0.00 we can consider, and at 1% level of significance, your alpha value is 0.01. So p value is less than your 0.01. Hence, we can say that your null hypothesis rejected. That is, there is a significant relationship between x and y. There is a significant relationship between time driving and distance traveled. And the third part, we have compute the coefficient of determination between the time driving and the distance traveled. Interpret the result in the context of the problem. So coefficient of determination can be calculated as your r square, and r square is your sum of squares of regression divided by sum of squares by total. So this divided by this one, and you will get that as your 0.99, that is 99.91%. So that means 99.91% of variability of distance travel can be explained by a linear relationship of the time driving. And that completes the problem. Thank you.